Okay, so we're moving on away from electricity and light bulbs and starting a little focus on magnets, which I actually think will be easier to handle from home. When magnet meets magnet. So as I read aloud and snap, it would be nice if you could say the word yourself at home for practice. You know what a refrigerator magnet is. It's an object that might look like a flower, a piece of fruit, or a seashell. And most importantly, it sticks to the refrigerator. Refrigerator magnets come in thousands of sizes, colors, and shapes, but they all have one thing in common. When you look on the back, you see a piece of black, flexible material or a hard black object. The flexible piece or black object that sticks to the refrigerator is a permanent magnet. The magnet might look different from the donut-shaped one you used in class, but it works just the same. The shape on the front is a decoration. It's the magnet that sticks to the refrigerator. The most interesting thing about magnets is that they stick to refrigerators and to a lot of other things, but they don't stick to everything. If you test all the different objects around your kitchen, you will soon discover that magnets only stick to some metal objects. So here in this drawing is an example of a permanent magnet on the back of a refrigerator magnet. The next video is an activity around magnets, and I do hope you might have some in your home that you can experiment with. Here are some other examples of refrigerator magnets, these fruits and fish. We're moving on here to page 31. After more testing, you will find that magnets stick to one kind of metal. That metal is iron. Iron can be mixed with other metals to make steel. Magnets stick to steel because steel is mostly iron. Magnets do not stick to objects made of most other metals. For example, magnets do not stick to aluminum pots, copper coins, silver spoons, gold rings, or brass hinges. The general rule is if a magnet sticks to an object, the object is iron or steel. When you bring two magnets together, two things can happen. Sometimes magnets pull on each other and stick together. When they pull and stick, we say they attract. So let's take a look at these photos. Unfortunately, we weren't able to do this experiment in class before we left, but you can see these are what they call donut-shaped magnets. And right now they are, boom, two magnets attracting. At other times, magnets push each other apart. When they push apart, we say they repel. Why do you think they repel? So these are two magnets that are repelling, moving further apart. And we'll experiment with that later. Magnetic poles. Every magnet has two different sides or ends called poles. One pole is called the North Pole. It's exactly where Santa is apparently living. So that is how you can remember that. It's the northern top of the earth. And the other is called the South Pole. A simple bar magnet has its two poles on opposite ends. A horseshoe magnet has a pole on each end of the horseshoe. The donut magnets you worked with have poles on the two flat sides. Magnets always have a north pole and a south pole. So here are the kinds of magnets they're talking about. A bar magnet. This is a horseshoe magnet, like the horseshoe on the bottom of Black Stallion's feet. And here are the donut magnets that we would have worked with in class. You might wonder what happens when a bar magnet breaks. Do you have a magnet with just one pole? No. Both pieces still have a north pole and a south pole. The same is true for all other magnets. No matter how many pieces you cut a magnet into, each piece still has a north pole and a south pole. So this is not an experiment we could have done in class because we don't have saws. But if you had a magnet and you really cut it down the middle, it's telling you that it will still always have a north and a south pole. Let's come over here. Excuse me. Better like that. What happens when two magnets come close to each other and you can feel them repel? How are the poles oriented? Do the magnets repel when two south poles come together? Do the magnets repel when two north poles come together? Or do they repel when one south pole and one north pole come together? Here are 4 pairs of bar magnets being held together. Which ones will push apart when they are released? So here, before I show you the answers, it's got 2 poles here. They're connecting the south side to the north side. Here, they're connecting the north pole to the north pole. Here, the north pole to the south pole. And here, the south pole to the south pole. So they're asking you, will they, boom, will they attract or will they repel? So take a guess, attract or repel? Attract, sorry, my fingers don't work that well. Attract or repel? Now let's find out the answer. This is what happens when the magnets are released. The 2 pairs of magnets on the left attract each other. The 2 pairs of magnets on the right repel each other. So what they're showing us here is, boom, these 2, the south and the north, they attract, they stay together. The north and the south, they attract, they stay together. But here, the north and the north, they repel. And here, the south and the south, they repel. 2 north poles always repel each other. 2 south poles always repel each other. We can state a general rule, like poles repel. A north pole and a south pole always attract each other. It doesn't matter which magnet has the north pole and which has the south pole. We can state another general rule. Opposite poles attract. Just checking. Okay, here we are. The magnetic force. Magnetism is a force. A force is a push or a pull. You can feel the magnetic force when you pull 2 attracting magnets apart. In the same way, you can feel the magnetic force when you push 2 repelling magnets together. The force of magnetism is what makes magnets act the ways they do. So this is a pretty cool photo here. It's using different little pieces of iron fillings, and you can see magnetic fields around magnets. These tiny little pieces of magnets, kind of like kinetic sand, They are moving in swirls around the magnets. How magnets stick to iron. If opposite poles attract, why does a magnet stick to a piece of iron? Magnetism extends out from a magnet in an invisible area called a magnetic field. When a magnet comes close to a piece of iron, such as a steel nail, the magnetic field interacts with the iron in the nail. The nail becomes a temporary magnet. The end of the nail becomes one pole of a magnet. The magnet then sticks to the temporary magnet. So, magnets don't really stick to iron. Magnets stick to other magnets. The magnetism in the iron is called induced magnetism. Induced magnetism happens only when a magnet is close by. If you bring the south pole of a magnet close to the head of a nail, what pole will the head of the nail become? Just apply the rule. Opposites attract. The nail head will become a north pole. The first magnets. The first magnets were pieces of a naturally occurring mineral called magnetite. Magnetite sticks to magnets because it contains a lot of iron. The black rock in your set of test objects is magnetite. When magnetite is by itself, it is called lodestone. Legend has it that shepherds found bits of rock sticking to the iron nails in their sandals more than 2,000 years ago. One area rich with lodestone was a part of present-day Turkey. This region was called Magnesia. The word magnet may come from the name of this ancient region. Magnetite is also found in a number of locations in the United States. Some of the major sources are shown on the map below. Can you find the major magnetite source closest to where you live? Now that's a good one. So here we are. We've got these. Where is the magnetite found in the United States? Looking for that red dot. I see some in New York, Minnesota, Arkansas, Utah. So where is the magnetite source closest to where we live? Well, here we are in California, so right here in Oakland. So what source is closest to us? Utah. And here's an example of magnetite coming from nature. And here's a drawing from that story. Lodestone was found in Magnesia, which is in Italy, and it was in Turkey, and they are sticking to these men's sandals. So, reviewing magnets. Magnets are objects that stick to iron and steel. All magnets have two poles, a north pole and a south pole. Like poles repel. Opposite poles attract. So these are the questions I sent you in today's morning message. Thinking about magnetic interactions. 1. Why does magnetite stick to a magnet? 2. What causes magnets to attract each other at some times and repel each other at other times? 3. The magnets shown below have one pole labeled. Which pairs of magnets will attract and which will repel? So, if you want to take a picture, or you could even draw these examples, which of these magnets will, boom, attract, or which ones will repel? So I'll be sending a next video with an activity for today for science. I hope you enjoy. Goodbye, my class.